The textbook does describe a type of active response that's called a deception response. What you're doing here, and this is where the term honeypot comes in, is that you entice an attacker to come into your system and you let them think that whatever they're doing is successful and is not being detected, where in reality you're aware of it. They've tripped something as they've come into this, but you can monitor what they're doing. And sometimes you can get more information about whoever it is that's doing this, or maybe you can even find out how they're doing certain activities. The book does say this is kind of a risky thing to do. Don't do it unless you really know what you're doing, and I think I would agree with that. The examples that we've talked about so far are network-based, where you've got a hardware solution that's your intrusion detection system that has all the different components that we discussed here. You can also have an intrusion detection system that runs on a host. It's a software package that runs on top of a regular operating system. It's kind of like the difference between a dedicated hardware router and a Server 2008 running as a router. It'll accomplish the same thing, but there's more overhead and more security exposure with one than the other. The next section here is entitled Working with NIPS, Network Intrusion Prevention Systems, and this kind of goes back to what I was saying earlier. An intrusion detection system, something has to happen for the intrusion to be detected, and then you can take action. Intrusion prevention systems theoretically are going to prevent an attack from occurring, but if you read through the text, it's kind of a matter of semantics. It still has to detect something before it can take any action. I don't really know what the bottom line is on this. I think in either case, something has to happen, and so you're going to be a little bit behind the curve no matter which option you take or what the package says that you're buying. Moving on to the section entitled Utilizing Honeypots, I think this is pretty self-explanatory. The idea is that you've got something that's attractive to hackers, and you can use this to your advantage to either trap them or to find out more about their methods. This section does discuss the difference between enticement and entrapment. Enticement is where you encourage someone or lure someone to your site to do something. And then entrapment is actually where you're encouraging or inducing someone to commit a crime. That part's against the law. You can entice somebody, but you can't entrap them. Frankly, I would say this is all above my pay grade, and somebody else is going to make these decisions for me. The last part of this section discusses incident response. And incident response is a 5-step process that helps you identify the incident, first of all, even knowing that something occurred. Then you investigate what happened, how it happened, what the damage was, try and repair that damage, and then you document and make sure that people know what happened. And then you adjust your procedures, hopefully to prevent this type of attack in the future. This is a standard 5-place cycle. And remember those 5 spots, because you're going to be asked about those 5 things on the test. You know, I think this is kind of straightforward. It makes sense, even though you may not have actually thought about this stuff before. The first thing is knowing that something happened, and that's where your intrusion detection system can come in, or your audits, or the fact that data is gone when it was there yesterday. There are lots of different ways to find out that something has happened. Once you know that something has happened, the next step, investigating, is trying to determine, okay, what's the scope of this? You notice that a file is missing. Well, what else might be missing? Was anything else compromised? Can you tell if data was copied that might be secure? So you go through and you look for logs. You know, a lot of times you'll look at your audit logs, who logged in at what time, and if you've got the correct amount of logging enabled, you can see if somebody copied a file or what they did. A lot of times people don't have this in place until after they experience an incident, and then they turn all this stuff on. After you have thoroughly investigated, and this can take a while, then your next step is to figure out how to get things back in production. Part of your investigation is going to make sure that a threat doesn't exist. You don't want to put things back in production without knowing, gee, did they plant some sort of a Trojan? Is there now software on your server that is recording keystrokes or sending files off to the internet somewhere? You need to be looking for all of those types of things. If somebody got in, you should really assume the worst and try and cover all your bases and see just what kind of exposure you have. Sometimes your damage is so complete that you just have to go back and grab your install CDs and get going. This falls into more the category of disaster recovery, and we've got a whole unit on that later on in the book. You do need to make sure that you document whatever it is you're doing. This can be for internal use, but it's also really important for any litigation that might take place. The forensic exams that I do are just normally on individual workstations, but I have a clear chain of evidence and I have a clear description of what it is I did, what test I used, what software I used, what I found. And I have usually a couple DVDs worth of just reporting information by the time I finished in analysis. Depending on where you go with this, you can either take it to law enforcement. Like if you find child porn, then you just go straight to the FBI with that, because that's who primarily investigates that sort of stuff. Documenting it is something that you need to make sure of. And I think the book talks about chain of custody, I guess they very briefly. With chain of custody, what you want to make sure is that whatever evidence you have, if it's a hard drive or if it's an entire system, you can't leave that unattended. It either has to be in your possession, in your sight the whole time, or it has to be like in a safe deposit box or a safe. If there's any kind of a break in that chain of custody, then that opens the door for the defense to say, well, we don't know what happened to it while it was in unattended. And then they can say that all of your evidence is tainted. Just something to keep in mind. If you do call in a professional to do some sort of a forensic exam, they should be able to guide you in terms of chain of custody stuff. The next section in the textbook is entitled Working with Wireless Systems. And it gives a rundown of the different wireless protocols. All of them run off of 802.11.x, and different enhancements are going to be the X where you've got a different letter. If you look back at the handout that I have in the Blackboard shell, that second table is information about wireless protocols. When wireless protocols were first created, 802.11 was the only one. But then we see that we've got 802.11a, b, g, and n, and then there are still more that have been added here. They switch between frequency at 2.4 gigahertz and 5 gigahertz. There's probably rhyme and reason to it, but what I find is I just have to memorize this stuff. Between the frequency and the bandwidth and the name, just figure out some way to remember it. The thing that I find kind of interesting is the encoding. But then again, when you're a nerd, all sorts of things are interesting that may not be to other people. There are three ways that you can encode wireless transmissions. The first one that they talk about is direct sequence spread spectrum, or DSSS. Essentially what that does is it transmits your data on a frequency, and then it piggybacks the same data at a different frequency, so the information is actually transmitted twice. It's redundant information, and so if something gets messed up from point A to point B, you've got two chances to actually receive the data correctly. The next option is called frequency hopping spread spectrum. And here you take a series of predefined frequencies. Let's just call it frequency 1, 2, 3, and 4. You'll send out a little bit of traffic on 1, switch to 2, then switch to 3, then switch to 4, and then back down the sequence. So you're constantly moving between those different frequencies, and there's timing involved with this, obviously, because the other end has to be able to pick up at the right frequency on the other end. This is called frequency hopping, and that name is actually pretty descriptive. The last option that we have is called orthogonal frequency division multiplexing. And here we still take the same 1, 2, 3, 4 frequencies that we might be using, but instead of sending it one at a time and alternating the frequencies, we send across all of those at the same time. It's kind of like a parallel cable. Got 15 strands and you're sending things down all 15 strands at the same time. And so that's what OFDM is. There will be questions on this table and on the encoding stuff on the exam. So I would make sure that you can memorize these things and that you know the difference between those three different encoding mechanisms. So the encoding discusses how you get your data from point A to point B. And one of the things that you want to do with your transmissions is you want to make those secure, and so you're going to try and do some encryption. There are a couple different ways that you can encrypt wireless data, and the oldest way is with WEP, and that does some encryption. It's also pretty easy to hack. Years ago, when we actually taught this as a face-to-face class, the assignments that I had the students do was see if they could, I would bring not see if they could go out and hack one. I would bring one in and then have them research and figure out just how easy it was to get around that. The information is readily available. Because WEP is inherently insecure, WPA was developed, and this is Wi-Fi protected access, and then there was a second level of enhancement there. And then sometimes when you're setting up devices, you'll also see that you've got WPA2 personal and WPA2 enterprise. They're all based on the same thing. It's a different type of algorithm. It does use a passphrase. If you have the choice, use the strongest encryption that you can use, which would be WPA2. One of the things that I had you do in this chapter is to go through and figure out 10 different safeguards for protecting your wireless communications. You can spend 10 minutes on the internet and get a pretty comprehensive list. There are a lot of things to keep in mind when you're using wireless access. Sure, it's real easy to do and it can be very convenient, but you should never assume that it's safe. You should actually assume always that somebody's looking over your shoulder. So be very careful about what you even do when you're using public wireless facilities. One thing that you can do is start up your public session and then use a virtual private network to connect into somewhere else, and that's going to keep your stuff pretty secure.